Last video on logs and exponentials, and this will answer some of your questions about what this weird number thing, whatever you've been calling it, e is. It actually represents a number, and if you were to type it in your calculator, there's two ways to type it in. If you hit second and then divide, it pops up the e. If you hit enter, it does tell you that it's approximately 2.72 or 2.718281.828 blah 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 blah. Keeps on going. And then the other way to get it is second and then the natural log button, which is next to the 4, and that automatically pops up with an exponent. So if you want it without an exponent, it's second divide, and then if you want it with an exponent, it's second natural log, which is next to the 4. So if I wanted to graph y equals e raised to the x, it is an exponential, so if we know what an exponential looks like, it's a growth function that goes up, left to right. And if we want to check it in our calculator, just go to y equals e raised to the x power, graph it, and it shows you it is a growth function. You can also have exponential equations with bases of e rather than a base of a number. So if I had the population of llamas on a tropical island can be modeled by the equation p equals 500 e raised to the 0.035 times t, where t represents a number of years since the llama was first introduced. I want to figure out how many llamas were initially introduced at t of 0. That means the first year that they were there. So p would equal, that's going to be the population of 500 e raised to the 0.035, and t is equal to the years. So I type that in my calculator. 500 times e, I want an exponent of 0.035 times t. I don't have a t button, so I can use my variable button, which is x, t, theta, and whatever it is. I get 700. Oh, I need to plug 0 in for x. So times 0. I get 500. The reason for that is anything raised to the 0 power, remember, is 1. I have a population of 500. Algebraically determine the number of years when the population reaches 600 and round to the nearest tenth. Whenever you're reading a regents, make sure you're reading it carefully because it will say round to the nearest whatever, and it will be italicized, but you need to read carefully because if you round wrong, you're missing a point. So I want to know when the population reaches 600. So 600 equals 500 times e raised to 0.035 times t. That's what I'm trying to solve for, is years, which is my time, so t. So I want to get rid of 500 first. If I divide 600 by 500, I would get 6/5 equals e raised to the 0.035 t. So again, I'm solving for an exponent, so I could take the log of both sides. So I have the log of 6/5 equals 0.035 t times the log of e, divide by both 0.035 and the log of e. Type that in my calculator. You get 5.21 approximately. Oh, round to the nearest tenth, 5.2. Now, talking about inverses. E is an inverse of a natural log. Natural log actually is the same thing as a log, but instead of base numbers that are whole numbers, it has a base of e rather than a base of 2 or a base of 10 like a log does. It's the same thing. It's just a log with a base of e. So if I were to type natural log of e in my calculator, they're inverses of each other, so that means they cancel out. So that gives you 1. If I have the natural log of 1, that has to be 0, because 0 raised e raised to the 0 power gives me 1. Again, natural log of e raised to the 5th. Natural log and e cancel out, bring my exponent out in front, so that will give me 5. And then natural log of the square root of e is the same thing as the natural log of e raised to the 1/2, because remember, power over root number. And I bring my 1/2 out in front, I get 1/2. Now it says without your calculator, but you will have your calculator on the Regent, so if you can't remember, you could type it in your calculator, because you have the calculator with you on the Regent. So using log properties, what's equivalent to the natural log of x raised to the 3rd divided by e raised to the 2nd? Well, we talked about log properties 2 lessons ago. So it's the same thing for natural logs. So if I have 2 parts, x and e, I'm going to have 2 natural logs of x to the 3rd and the natural log of e to the 2nd. What do you do when you're dividing? You subtract the logs. So I'm subtracting between them. And then log properties say I can move my exponents out in front. So I end up with 3 natural log of x minus 2 natural log of e. And the natural log and e are inverses of each other, so they cancel out, which gives me 1. So I end up with choice 2 as my answer. Number 5, a hot liquid is cooling in a room whose temperature is constant. Its temperature can be modeled using the exponential function shown below. The temperature T is in degrees Fahrenheit and is a function of number of minutes M has been cooling. So T of M is equal to 101 times E raised to the negative 0.03 M plus 67. Fun. So what is the initial temperature of the water at 0 minutes? So T of 0, because I have 0 minutes, equals 101 E raised to the negative 0.03 times 0 plus 67. It says do it without your calculator, but if you're stuck, you can use your calculator. You just have to be careful when you type it in the calculator. So you have 101 times e raised to the power of negative 0.03 times 0, so I put it in parentheses, plus 67 gives me 168. So T of 0 equals 168. How do you interpret the statement that T of 60 equals 83.7 or 83.7? So remember, T represents temperature, so that means 83.7 is temperatures, which is measured in degrees Fahrenheit, so that means 83.7 degrees Fahrenheit. 60, according to this equation, is M, which stands for minutes, so I know that's 60 minutes. Oops. Using the natural log, determine algebraically when the temperature of the liquid reaches 100 degrees Fahrenheit. Show your steps in your solution and round to the nearest tenth of a minute. So this is the second to last problem for logs, which is exciting. So I want to know when it reaches 100. So that's going to be 100 equals 101 times e raised to the negative 0.03 t, oops, m, in this case, we're talking about, plus 67. So in order to solve for m, I have to get rid of all the stuff around it. So that means I have to get rid of 67, so I'd minus 67 on both sides. So that would give me 33 equals 101 times e raised to the negative 0.03 m. Now what would I do to get rid of everything else besides my variable m? That means I have to divide by 101. Now 33 divided by 101 is not going to come out pretty. So we're just going to leave it as a fraction. 33 divided by 101 equals e raised to the negative 0.03 m. Since we know that natural log and e are inverses of each other, I could take the natural log of both sides rather than the log, which means the natural log and e are going to cancel out, leaving me with just my exponent, which I can move out in front. So I have the natural log of 33 divided by 101 equals negative 0.03 m times the natural log of e. Remember, they're inverses, they cancel out, they're 1, so that's gone. And then, to get rid of negative 0.03, I would divide. The only thing you have to be careful about when you're dividing those is you need to make sure you close your parentheses again. So natural log of 33 divided by 101, close my parentheses, divided by negative 0.03. I get m equals 37.28. If I round it correctly, it'd be 37.29, which ends up being approximately 37 minutes. Whoops, not 33. Next problem, it says on average. Remember, when you're finding average, you're dividing how many degrees are lost per minute over the interval 10 to 30, round to the nearest tenth of a degree. So that means I need to know my temperature over my minutes. So I'm going to plug in 30 into my equation. 101 times e raised to negative 0.03 times 30 plus 67 minus 101 times e raised to the negative 0.03 times 10 plus 67, all divided by 30 minus 10. And if you were stuck with which would go on top, it says degrees are lost per minute. Per means divide, if you didn't know that. So I need to type all this in. My suggestion to you is to type it in individually so you have an approximation of everything. So the first one, if you type in 30 for my time, my minutes, I would get 108.0635356. And remember, if you need the other value and you're only changing a number, you can hit second enter, which will give you the entry button, and just change what you just typed in. So instead of 30, I change it to 10, which will give me 141.8226, blah blah blah. So you get 108.0635 minus 141.8226, Now, if it says round to the nearest tenth, make sure you go out further than the tenth when you're rounding, so you get an approximate answer. Divided by 30 minus 10, which gives me negative 33.7591, divided by 20, which gives me negative 1.688, which is round to the nearest tenth of a degree, negative 1.7. Now, does it make sense that it's negative? Yes, it does, because I'm losing degrees, so it should be a negative. So I'm approximately losing 2 degrees every minute. And that's the end of vlogs. So you have 2 more videos on sequences, and you are ready for this Regents. Come to the reviews, study on your own, watch practice Regences, YouTube Regents practice, whatever you need to do to get ready. And I will see you tomorrow in class.